Hey, all you campers out there. We are going to start chapter 12. So, chapter 12 is going to be very different than the rest of the sections that we've looked at. Um, a lot of people haven't seen this stuff before. Sometimes you see it in like an Algebra 2 class, but most of this stuff is new for most people, which is fine. So, we're going to be looking at sequences and series and seeing what you do with those. So let's go ahead and define sequences. That's what we're doing in this section. So sequence is a function whose domain is n, or the natural numbers. The natural numbers are the numbers you count with. So it starts with 1, and then 2, 3, 4, 5, 6, 7, 8, 9. So that's the domain. So it's pretty restrictive. So no fractions, no zero, no negatives. Yeah. It's usually written in an ordered list, and then each number in the list is called a term. Now, every sequence has a general term, and this is the nth term in the list. And you can kind of think of it as like the function that kind of generates the terms out. That's the nth term. So notation for sequences is sometimes I'll have these curly brackets surrounding like an a sub n, or sometimes an actual function. But when you see these curly brackets, that's supposed to say, hey, we're looking at a function. Or sometimes I can just leave them off. So like that. This is kind of more typical, but you'll see this one as well. All right, so let's go ahead and practice these. So write down the first 5 terms of each sequence. So here they've given you the sequence, and like this thing in here, that's the nth term that we were talking about. It's the generalized thing. So they want the first 5 terms. So you're gonna use the domain of the natural numbers to get them. So plug in n equals 1, and if you do, that would give you 1/3. Well, now plug in n equals 2, and that would give you 2/4 or 1/2. Plug in n equals 3, so 3/5. N equals 4, 4/6 or 2/3. And then finally, n equals 5, and you get 5/7. And so that's how you generate the terms in your sequence. So we could keep going, and it would go on for infinity, or go on forever, but we only want the first 5 terms. So let's go ahead and do part B. So you're going to plug in 1. So that would make the exponent a 2. So negative 1 squared is a positive. And then 1 squared is positive 1. So you get 1. Plug in the 2. Well, now you have negative 1 to the 3rd, which is a negative. And 2 squared was 4. Plug in 3. You have negative 1 to the 4th, so that's a positive. 3 squared is 9. And a lot of times, once you start like kind of getting your terms out, you can kind of identify the patterns. Like, oh, I'm really just squaring the number I'm plugging in, and it's alternating in sign all the way down. So if I plugged in the 4, it'd come out as a negative 16. Plug in 5, positive 25. If I plugged in 6, negative 36, and so on and so forth. So that's how these sequences generate their terms. So I'll let you look at parts C and D, and let's move on to the factorials. So factorials, these are the numbers that have an exclamation point after them. So like these down here, so it's not saying, don't say it super loud. It's not like 3 or 5. It's not a grammar thing. It's an actual operation. So what it says to do is you take the number, and then you're going to multiply it by every integer that's lower than that number, stopping at 1. was like, wait, what did he say? So you're going to take the number and then you multiply it by every integer that's behind it or smaller than it. And then just to note, 0 factorial by definition is equal to 1, as well as 1 factorial. That's also equal to 1. All right, so 3 factorial, you just take the number itself, so take 3, and then multiply by every integer that's lower, stopping at 1. So that's going to equal 6. So the 5 factorial, that's 5 times 4 times 3 times 2 times 1. Multiply that out and you get 120. Technically you don't need the 1 in there, but you can leave it out or put it in either way. Now these, you're like, oh my gosh, we have to figure out 9 factorial. Well, sort of. You got to do the division in there as well. So 9 factorial, you know, that would be 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. Well, 6 factorial, that's 6 times 5 times 4 times 3 times 2 times 1. Well, you notice something that you could do? Yeah, you can go zip, zip, and cancel all that stuff out, and you're left with 9 times 8 times 7, which is 504. So when you see these things, don't panic. They're going to reduce down because of the way the factorials work. Okay, so let's look at this one. 9 factorial times 2 factorial, all divided by 7 factorial. So that 7 factorial, that's going to do something similar to what this did. It's going to knock out the 7 all the way down from that 9 factorial. So you'd be left with the 9 and the 8. And then you're still left with 2 factorial. Well, 2 factorial is just 2 times 1. So 9 times 8 times 2 times the 1 gives you 144. Okay, so we'll stop the video here and then we'll continue on in the next one.